Hi, everyone. I'm Arjun Chandar, CEO of Industrial ML, and I'm having a conversation today with my cousin, Shyaam Ramkumar, about the sustainability benefits of industrial IoT platforms, both within manufacturing facilities and across entire value chains. So, Shyaam, thanks for joining me.
Thanks, Arjun. Nice to meet you, everyone. As Arjun said, I'm Shyaam Ramkumar. I've worked in the sustainability space, most recently focusing on the circular economy for many years. And yeah, been interested in the topic of technology and platforms, IoT, et cetera, in sort of accelerating the transition to a more sustainable and circular society. And really excited to talk with you, Arjun, about how technology can really be that enabler for creating not only business benefits but sustainability benefits as well. So Arjun, yeah, really curious to hear how you guys work with technology and really use technology to support, companies making that that transition to provide some significant business benefits for them.
Yeah, absolutely. What we're building at Industrial ML is a comprehensive data integration and analysis platform. And I've posted a few videos about some of the things that we do in the past. I had an interview with my principal software architect, Jason Truesdale, about some of the challenges that we face with data integration in legacy factories, because we started out in the steel tube industry. I've also talked a little bit about one of the analysis tools that we can enable, which is real-time computer vision. And all of these tools collectively are ways for factories to monitor their data in real time, generate alerts, and be alerted to critical production issues as they happen, instead of, say, 30 minutes after the fact. And finally, to be able to generate reports on that data and be able to analyze it offline as well. Now, the benefits of being able to do all of these things are multifold, of course. But the biggest business benefits that we see with factories are the ones that you would most expect. That with being able to catch issues earlier and resolve them more quickly, they're able to increase their overall factory uptime. And at the same time, they're able to reduce the amount of scrap that they generate. That's not just because they're able to, identify scrap materials and shunt them aside more quickly and just prevent them from getting to the customer, although that's, certainly part of it. But because of the fact that they're able to identify, issues in real time and be able to predict issues in real time, it prevents them from wasting their time and their energy, of course, running products through their line, which end up not being of any value add to the company at all. So there are, of course, tons of business benefits just with the intra-factory setting to that. So plenty of business benefits, of course, but I think for the purposes of this conversation, what's most interesting and valuable are the sustainability benefits of being able to do that type of monitoring. For instance, with just steel production, 1 ton of steel can use up 1.9 tons of CO2. And
Right.
there's a huge benefit to being able to say that we ran the factory 80% of the time, and every bit of that 80% was used to produce material that's actually being sent to customers instead of thrown away.
Yeah, I mean, I think some of the things that you mentioned in terms of the savings that people see from a financial perspective have that corollary to a material perspective and environmental aspect as well. I mean, as you said, I think there's of course energy savings that companies can gain as a result of more closely monitoring their production processes, and that directly translates, of course, to environmental benefits through the reduced use of energy and fossil fuels, et cetera, depending on the grid that they're in, of course. But yeah, I mean, more directly, there's also elements of just being able to reduce the need for virgin materials. So this aspect of dematerialization as a result of being more efficient in the production process. So that's it on the one hand, and then as you said as well, there's reduced waste and scrap being generated. So on that aspect, there's less material that's being thrown away and more material that actually ends up in the product, which of course has significant benefits. And yeah, I think technologies like yours that really allow organizations to understand their operations and optimize them can really provide some significant value from an environmental perspective as well.
Absolutely. And of course, there are plenty of I'll say green benefits when it comes to both, you know, machine efficiency and human efficiency as well. And perhaps we can get into that in a future conversation. Uh, but certainly, just focusing on the material benefits from a sustainability standpoint is something that we can probably riff about for hours on end.
Right, right.
Yeah.
No, it's true, exactly. And in addition to like, I think companies' operations themselves, what has really been interesting, at least from the field that I'm in with sustainability, is a sort of use of technology to really connect multiple companies together in order
Yeah.
to allow them to use technology as a way to identify across value chains, across industrial networks, et cetera, how do you find those material efficiencies? Particularly from the perspective of these platforms. And I think, that's what we wanted to kind of get into a bit today. Really, how do you kind of find those material inefficiencies more at a systematic level,
Yeah.
and really allow these organizations to use technology to connect with each other and identify areas of opportunity where they could optimize their use of resources and materials, and also identify ways that they can reuse scrap and waste from one process to another, so they're
Yeah.
not just throwing it away.
Yeah, absolutely. One of the things that I would really like to do with industrial ML as we grow from being a startup into a growth business is move past the concept of just the intra-factory benefit and
Right.
get into being a trusted partner all across value chains. Uh, and I know that there are some platforms that focus on being able to be a marketplace for materials exchange, for raw materials exchange, virgin materials and reground materials. Um, but I've seen that there is a gap in the marketplace when it comes to uh, being, say, like the JD Power and Associates of material quality, of being that entity that can ensure material quality and guarantee material quality across these types of exchanges. I know you've had more experience in seeing some of those challenges. So
Yeah, as you said, there's lots of examples of really nice materials exchange marketplaces. There's the sort of excess materials exchange. There's some local ones as well. I just came across, the city of Austin has a materials marketplace. And yeah, these platforms are essentially great ways for companies to be able to connect with each other and send waste materials for other uses rather than to the
yeah,
landfill, or to the waste bin. And yeah, these platforms, one of the big challenges when I was working with them in Europe is primarily this idea of how do you kind of verify or certify that the what's being posted on these platforms is accurate. If someone says that they're selling 10 tons of steel, how do you know it's actually going to be 10 tons? Can you certify that? How do you know what the quality of that material is? Will it actually be fit for purpose for the use case that the buyer wants it for? So yeah, I think some of these platforms are kind of identifying ways to address these kinds of issues. And I think, yeah, as you said, like some kind of way to certify and verify and place trust in these kinds of technology and platforms will really open them up to a lot of interesting use cases for the industry, in order to be able to connect them to identify some of those business benefits, but also sustainability benefits.
yeah, and we're trying to navigate as we think about that. Is supply chains have become much more globalized over the last 20 years, but trust between countries has eroded a lot, especially in the last 5 years. Um, And so I'm not sure if you've seen any examples of ways that third-party systems can build up that trust to say, be that way to ensure quality within, say, a materials exchange. Uh, I haven't really seen great examples of how that trust gets built, other than just being right most of the time.
Right.
But you've certainly had more experience working with governments than I have, for instance. So yeah, curious to hear how you think those work.
Yeah, I mean that's a good question. I think with the platforms that I've seen, at least mostly had experience with looking at a few platforms in the textiles industry more so than any kind of heavy industry. And at least there, I think there's a few sort of certification bodies or firms that kind of are responsible for making sure that they are able to audit and validate the materials on these platforms. And I'm sure there's probably some level of that happening with some of these materials marketplaces as well. But of course, there's also, like, I think, technology solutions to that people are coming up with, and trying to identify how they can create systems that are able to verify the quality of the materials coming in. I know that in this is not directly related to things like steel or others, but in the coffee industry, for example, this company Bex 360, they had these kind of machines in these coffee farms where they would basically identify the quality of the beans, and their entire kind of model was to pay the farmers based on the quality of the beans that they harvested, and then that quality would get recorded in their database, so you can identify which farms have which kind of quality of beans, et cetera. And I'm sure that there could be an application of that kind of model to the industrial side as well, especially with some of the things that that you guys are using.
Yeah, I mean, I think a good example that we've seen, which is very similar to that, is in the mining industry. And we've spoken to a couple of companies that are looking to use machine vision, either on their excavation trucks, or in some cases even on their shovels.
Mm-hmm.
It's not necessarily to look at the quality of the ore that got blasted, although that certainly is a potential use case. But they're looking at the size of the ore pellets after an initial blast, because if those pellets are too big, then your excavator could get broken when you try to grind them further.
Right.
Now that's somewhat of an intra company type application, but even if you're thinking about the entire mining value chain within the context of one company, you can assess which sites or which excavators or which forms of blasting, blasting compositions yield the best results in terms of the types of ore pellets that you generate. And you can use that to ensure more consistency across all of your mining sites. So those types of applications exist on the industrial side certainly as well. And I mean, I also wouldn't consider coffee non-industrial by any stretch. So yeah.
Right. No, that's true. Yeah, I mean, it's super interesting, right? Like, especially once you string these technologies together. So having something like machine vision at the beginning of the stage in order to identify the quality, the consistency of these materials, having a platform connected to that to then make available these materials for exchange in a fashion that makes it more easily accessible to companies and able to connect them. And then, once companies have received those materials, having technology systems within the company itself or within a facility in order to optimize the use of those materials so that, as you said earlier, you get more product, less waste, and more optimized use of energy and resources. So yeah, what I find fascinating about all this is just the ability for multiple technology components to be able to kind of be linked to each other in a way that makes the whole process more efficient, rather than thinking about it in terms of just a siloed application.
Now, I know that one of the challenges that you've faced in your background in circular economy is that uh, when there are multiple companies involved, or even multiple divisions of the same company, or multiple cities, um, that particular communication challenge becomes very, very difficult. And finding platforms that multiple entities can communicate on is very difficult. I don't know that there's a great solution to that that's been developed just yet, but what are some of the things that you've seen that people try to do to overcome those challenges?
Yeah, I mean that's a big problem. I think it's still, I think, difficult for companies to really open up in terms of what kind of data they gather and make that sort of available. Of course, you run the risk in doing so of like giving away your secret sauce or giving away
Yep.
IP or things like that your competitors can take advantage of. But yeah, I'm really curious with technology, to what extent do the benefits outweigh some of those risks? And how much better is it for the whole system as a whole, if all these companies are able to be more transparent? I mean, like when I've done projects in the past in the waste industry, like even with waste data, it's very difficult to get exact information about the sources of those waste streams, because companies are afraid that even if you look at their waste streams, you'll be able to somehow reverse engineer or understand their processes just from having that little bit of information. So very, very close-walled in terms of what they're able to give
Yeah.
away. And yeah, I don't know that there is a good solution. I think a lot of organizations or groups of companies are trying to experiment with things like like private blockchains and things like that, where only certain people have access to certain levels of information.
Yep.
And perhaps there are technologies that allow for having different access rights for different entities, so that only trusted parties are given access to the level of information that would be beneficial in a certain use case.
Yeah. I mean, I know something that we're very interested in exploring as we grow, and this actually goes back a little bit to the trusted entity to ensure supplier quality statement as well. Is
Right.
um, a factory may not want to sell its to make its data available to its suppliers or to its customers necessarily, but they certainly could make that data available in small chunks. But they could also make that data available to insurance companies, because A, the mere fact that they're collecting that data does give them higher odds of being able to catch issues. And B, it actually can be a proof point that they aren't sending defective products to their customers, or they're not putting their factory at risk in the way that they run it. And that can help them lower their insurance premiums. And in turn, insurance companies can issue ratings that potentially could be a trusted source of information. I mean, and they inherently are companies that can breed that type of trust, because if they assign something a high rating and then it happens to fail, they would be the ones who are liable for that failure.
Right.
So that's not quite what you consider a private blockchain. It's
Right.
more of an insurance company as a third party intermediary, but
Right.
it is a way in which you could potentially encourage sustainability across value chains, and have a trusted partner, and make data available and valuable to keep on a long-term basis.
Yeah, and I mean, in addition to, of course, sustainability element, I think bringing in the insurance companies brings in that business aspect of it as well, as a sort of de-risking strategy. You don't want to, increase your premiums or be at risk of increasing your premiums or being liable for anything. So yeah, totally makes sense. I think there's this aspect, I think, of the discussion with technology in terms of, to what extent do you over-engineer a solution? So
Yeah.
perhaps there's ways to address those challenges, like with your example, with just getting other sectors involved or other organizations involved, rather than necessarily, you know, investing a lot of time and resources in technology solutions that may or may not work. So what are maybe some smarter ways to do it? You know, recognizing that technology, of course, has a lot of benefits and has significant ways to improve the situation in certain use cases, but there may be other cases where, you know, just involving a third party or involving certain entities is perhaps a lower hanging fruit, better solution than creating this very complex system.
Well, and I guess just a quick plug for your work. I think that some of the agent-based modeling stuff that you've done and that you're doing with your company going forward could help identify who some of those third parties are who could most benefit.
Yeah, exactly. I mean, I think some of the stuff that I'm doing is really trying to understand you know, how are organizations connected to each other, in what ways can they leverage those connections in order to increase the sustainability of different kinds of value chains and really spread environmental circular economy innovations in a meaningful way. And yeah, I'm a totally a firm believer in sort of the power of networks and being able to find the right people to connect with, the right partners to get on board, where the sort of sum is greater than the parts. And yeah, finding those win-win situations can be quite difficult, but I think that's where, you know, technology really has that benefit in being able to identify the right connections to make, the right partnerships to form, et cetera. So you find that win-win situation in different cases where everybody benefits. And then we all do, of course, from a sustainability perspective.
Yeah, no, I mean, we've talked a little bit about obviously platforms with intra-company settings and the potential platforms to, you know, connect companies to supply networks. But there's the other side of it as well, which is, you know, connecting companies to the customer networks. And I think from a material standpoint in particular, that's really valuable when it comes to monitoring the products that you send out all the way to the end of life.
Right.
And I know that you've actually suggested a pretty interesting company, buildings as material banks, I think is what you called it, right?
Yeah, so that one is quite interesting. Yeah, it's an initiative that started, I think, in Europe, where they basically are looking at the construction industry to kind of understand within a building, what are the different kinds of materials going into it, and how can we, instead of just demolishing buildings, how can we encourage the construction and demolition industry as well to really look at buildings as sort of urban mines? So what kinds of materials are sort of embodied and kind of stored in all of our buildings and just built infrastructure in general, if you think about it, and how can we kind of create a platform or a system that, you know, really captures during the construction phase all of the different kinds of materials that go into a building and almost give it like a building passport. I think that the term they use is a materials passport for different buildings. Yeah. So that, you know, years down the line, you know, buildings have 100-year lifetimes, 100+ year lifetimes. When that building is ready to be demolished or ready to be deconstructed, hopefully, that there's a sort of record of what went into that building, and also, you know, over time, if there are any renovations that take place, that record is updated as well. And there's a record of all the kind of materials that are there that are valuable to be able to be recovered for different uses. So how can companies really in the construction and in the deconstruction demolition industry have an understanding of how can we kind of recover some of these materials in these buildings? What is the sort of value of the building at the end of life when you look at the material perspective, so that we don't just, you know, fully depreciate buildings, but recognize that there is some inherent value left over in them. And Yeah, I think it's an interesting concept that can probably be translated to a lot of other industries as well,
Yeah,
in terms of thinking about, what is the material value of different things that we produce.
certainly in manufacturing, I know that it can. And so our company's launch partner is Daiwa Steel Tube Industries, and one of the things that as they consider their grand vision for using our platform, one of the very early things that they told us was we don't really know what happens to our product once it leaves our facility. So they talked about it a little bit more in a business context of we don't necessarily know how many defective tubes we end up shipping to customers, and they don't always tell us. We just might lose them. uh, and so certainly there's internal value to knowing that. But if you expand that a step further, like it's really valuable to know this batch of tubes was defective, or this batch had this many defective tubes, or this many tubes that only lasted 6 months instead of lasting 18 months. And because you're capturing all of the data from when those tubes are produced, you can go back and you can see what the conditions of your line were that most led to potentially defective tubes that get out to the customer. And you can correct for those. Now, obviously, that's not something that you can do right away. That's going to take a year plus of data within a steel tube factory, and for almost any industry, it's going to take that type of data. But it is something that, if you're thinking about the long-term prospects of your company, can be really valuable. Obviously, you also talked about the salvaging of materials, and in any manufacturing context, that can be valuable as well. I don't know how much recycling steel can help with most types of steel production, but I think it can certainly, and there are tubing mills or rolling mills more precisely who would use recycled steel in generating their rolls. I see it as much more common in, say, like the plastics industry, where reground plastic can be extremely valuable, and works just fine for any number of consumer applications. For instance, in the 3D printing space, I know that tons of different industries, whether it's miniature consumer products all the way up to potentially building houses, are looking into using non-virgin materials in order to both be sustainable and reduce the total amount of cost that they extend, especially if they're trying to build affordable housing with it. So there are tons of applications in manufacturing for exactly that type of concepts. Really looking forward to seeing what we can contribute to that.
Yeah, no, that's super exciting. Yeah, and I think the end of life of things. Of course, when products start out, I guess it's quite simple in terms of the purity of the materials they use, and then across the production process, it just there's all sorts of transformations that happen to it, and I think having some sort of understanding of like what are those transformations that do happen,
Yeah,
just makes it that much easier for those materials to be recycled or reused by people in the beginning of the chain, because yeah, I guess you don't know like what kinds of alloys have been formed or what kinds of mixes have been created in
right.
that whole cycle, where if you're trying to recycle materials, that quality element is having an understanding of like what kinds of transformations have gone into this material that I can actually like more effectively reuse instead of completely breaking my machines. I can imagine that can be quite valuable, and I think especially as a society, I think we are demanding of our companies to have more sustainable products, materials made from recycled content, etc., which is then putting pressure on, I think, a lot of manufacturers and the industry in general to find solutions for that.
Yeah,
And that process becomes much easier when you have technology supporting that effort to really help them understand, what is able to be recycled, what is more effective to be recycled, and how do we also even just reduce the amount of waste that is non-recyclable, so that we make that process more closed loop and more circular. So yeah, really excited to see how all these different technology elements can really come together to make that happen.
So, Shyaam, it's been really, really nice talking to you about all of this today. Looking forward to doing this again in the future, because I know we've only just scratched the surface of all of the different topics related to industrial IoT, sustainability, and their effects on manufacturing.
Yeah, I really enjoyed it as well, Arjun, and I'm excited to see, as well in terms of reactions to this video, or people who heard this talk, to see if there are particular areas that they'd be interested in exploring further. I think we touched upon a lot of different topics when it came to technology and industry. So there's some really interesting deep dives that can be done as well. So would love to kind of explore some of those further with you.
Yeah, absolutely. All right, Shyaam, until next time.
Yeah, take care, Arjun.